is in the form a plus ib. And this a and b, these are real numbers. And the I is square root of -1, which is the complex part of this number. Now, we can write this complex number on an Argand diagram. An Argand diagram is more like the x or y plane. It's just the same as x or y plane. But because this is complex numbers, we don't call it the x or y plane. So the x-axis is called the real part, and then the y-axis is called the imaginary part. So when you've got a complex number z, which is in the form a plus ib, this means that the a is, you can see that's the real part of the complex number. So this is where the a is going to be, on the x-axis. And then the b is the imaginary part, so that is going to be on this axis. So if you want to write z as a coordinate, z is going to be equal to a comma b. This I, don't worry about it. It is just meaning that that number is on the imaginary part. So the coordinate is going to be this one here, a comma b. I can join with the origin or with the point 0 comma 0, like something like that. Though not good. Okay, like that. And then I can make something like that. So what I've made now is a triangle. And the distance from this point to the maximum point there is the same distance as from here up to here. This is what? This is b, which is also y. Like we are going up. That is the y coordinate. And then we have got the distance from here up to a. That is a, which we can also call x, because that distance is on the what? On the x-axis. Now, we have got this angle which is here. This is what we call argument. That angle is called the argument. Now, from your SOHCAHTOA, so tan of theta is given by opposite. You look at the opposite of this angle. The opposite is this one, y, over adjacent. And the adjacent to this angle is this side, which is a, or x. So this is how you determine the argument of a complex number. Tan theta is equal to y over x. Now, because in mathematics you don't use a calculator, I want to give you special angles and how you can find these angles without using a calculator. So before we get into the calculations, we need to understand how to find angles without using a calculator. Of course, we are going to do this. We are going to be starting functions. And one of the functions we're going to be looking at, trigonometric functions. So we're going to look at this, special angles. That's the first thing we're going to do in trig. Now on the special angles, we've got 30 degrees, 45 degrees, and 60 degrees. Starting with the 45 degree special angle, what we use is called an isosceles triangle. An isosceles triangle is a triangle that has got two sides which are the same. So it's more like this. This side is the same as this side. And here it is making 90 degrees. Now, you know that a triangle should add up to 190 degrees. If this is 90 degrees, that means these two also should give us 90, so that the total is going to give us 180. And so, because this side and this side, they are the same, meaning that also these two angles are the same. So divide 90 by 2. That is going to give you 45 here, also 45 there. So what you are going to do when you are using this kind of special angle, you take each side to be the same. Now, these two sides which are equal, they are going to be taken as one unit. So you take this one as one unit. Since it is equal to this one, also this one is going to be one unit. Now, using the Pythagoras theorem, this side you can see here is the hypotenuse. So we want to determine the hypotenuse. So the hypotenuse is given by the square root of two sides squared like that. So our x is going to be equal to 1 squared plus 1 squared is 2, and then square root, so that is going to be square root of 2, meaning that the hypotenuse here is going to be the square root of 2. So from here now, please, you need to know this, at least even if you don't master everything that we'll be talking about. So now let's talk of what to be tan 45 degrees. Don't forget the SOHCAHTOA. So tan is given by opposite over hypotenuse. If you take this angle here, it doesn't matter which one you take. If you take this 45, opposite is going to be a 1 over hypotenuse. This is square root of 2. So tan 45 is the same as 1 over square root of 2. And then if you come to sine of 45, sine you can see is given by opposite over hypotenuse. And actually this one I've done is for sine, because we are saying sine is opposite to this angle. Opposite is this one over hypotenuse, which is root 2. And then now for tan 45, tan is given by opposite over adjacent. So if this is the angle we're talking about, opposite is going to be this one over adjacent. Adjacent is the side which is next. The adjacent is this one. So it will be 1 over 1. So tan 45 is a 1. And then we can talk of cos 45. Cos 45 degrees is going to give us, we can see cos is adjacent over hypotenuse. The adjacent is this side, which is a 1. The hypotenuse is a square root of 2. So from what we're able to see here is that sin 45 and cos 45, they'll give you the same answer. If you want, you can confirm that with your calculator. Sin 45 is 1 over square root of 2. Now you leave it in sad form. You don't find the exact value. Alright. Apart from this, now since you can see that sin of 45 is 1 over square root of 2, this means that if you're talking of sin inverse of 1 over square root of 2, this is supposed to give you 45. So this is just a simple operation. In other words, if I take sin this side, sin inverse of 1 over root 2 is supposed to give me 45, just like sin 45 is giving me 1 over root 2. And same here, sin, this is tan inverse of this number which is here, which is a 1, is supposed to give me a 45. And same, cos inverse of 1 over root 2 is supposed to give me 45. As simple as that. Now, when you are dealing with the other special angles, is the 30 degrees and the 60 degrees. And here what we are going to use is an equilateral triangle. So when you're talking about an equilateral triangle, it's simply a triangle that has got all the sides the same. So what we are going to do is we are going to draw this triangle. All the sides should be the same. Since all the sides are the same, meaning that even all the angles are the same. So this is going to be 60. This is going to be 60. Also, this is going to be 60 since all the sides are the same. And for this triangle, what we do is we are going to take each side to be 2 units. It's units, not centimeters or meters or whatsoever, just units. So when you do that, I'm now going to cut this triangle into 2 halves on the very middle here. The very middle. That means this distance is going to be 1. This distance is also going to be 1. Since I've cut it on the middle, this is now going to remain as a 90 degrees. And since this was 60, I've cut it on the middle, this is going to be 30. So when I get this one, now I'm going to remove this part. So this is a triangle that we remain now with, which is a 90-degree triangle. So from here, we can work out what will be sine of 30 degrees. So sine of 30 is given by sine 30 degrees is here. Sine is given by what? Opposite over hypotenuse. Opposite is 1, hypotenuse is 2. So sine of 30 is 1 over 2. What of sine of 60? So sine of 60 is also opposite over hypotenuse. But notice that we don't have this side here, which is the opposite to 60. So we need to find this. Now we know the hypotenuse and we know one side. How can we find one other side? So that side which is missing is given by the hypotenuse squared minus one other side which is given squared, and then you square root. This is the Pythagoras theorem. 2 squared is a 4, 4 minus 1 squared is a 3. So that is going to be square root of 3, which is this side. So sine of 60 is going to be opposite, which is square root of 3, over hypotenuse, which is a 2. And then we can go now to cosine of 30. We can see cosine of 30. Where is 30? 30 is here. Cosine is given by adjacent over hypotenuse. And the adjacent to 30 is this side. The hypotenuse is here. So this is going to be square root of 3 divided by 2. And then cosine of 60 is also going to be given by cosine adjacent. Now adjacent here we can see to 60 is a 1, hypotenuse is a 2, so that is going to be 1 over 2. And then if we go to tan of 30 degrees, tan is given by opposite over adjacent. So 30 is here, opposite is here, adjacent is here, so it is 1 over square root of 3. And then if you are talking about tan 60 degrees, this is going to give you tan opposite over adjacent. So opposite is root 3, adjacent is 1. That will be root 3 over 1, which is simply root 3. So these are the special angles that we need to know. If tan 60 is giving us root 3, that means that tan inverse of root 3 is going to be 60. So these are very, very important for you to know, because when you are working out operations in mathematics where you are not expected to use a calculator, you're supposed to use this. Okay, we can now work out how to determine the argument of complex numbers since we know the special angles. By the way, if you don't know, or if you have not gotten what you've said, you can ask. Be free. Now, let's say we've been given a complex number z, which is equal to 1 plus I. And the question is, find the argument of this complex number. So to be able to find the argument of this complex number, the first thing is you need to know in which quadrant this complex number is. Okay. So if you look at this complex number, the real part is positive. The imaginary part is also positive, meaning that this complex number is going to be in which quadrant? So you are looking for where x is positive and y is positive. So it is in the first quadrant. So this is where this complex number is going to be. Where the x coordinate, we can see it is this one, which is a 1. Then the y coordinate is just a number in front of I. What number is in front of I? It is also a 1. So to find the argument, you are going to say tan theta is given by y over x. So that is going to be tan theta being equal to y. If we see y here is 1 divided by x also is 1. And that will be 1 over 1, which is simply 1. So to be able to find theta, we're going to say theta is going to be equal to, we're going to more like take tan the other side, it becomes tan inverse. But we don't take tan the other side, we multiply both sides by tan inverse. So that will be tan inverse, 1 over 1 is a 1. And from our special angles, if we go on tan, what is going to give us a 1? So we need to remember that. Okay, we are here. We can see this one here. Tan inverse of 1 is a 45 because tan 45 is a 1. So therefore, theta here is going to be equal to 45. This is the argument of this complex number. That is how you get to determine it. Anyone left behind? Are we all good? All right. Let's say we've been given a complex number z, which is equal to, let me just check something before I give that. Okay. So we have got the complex number z, which is, let's say, square root of 3 minus I. And we want to find the argument of this complex number. Question is, how do we find it? To be able to find it, first of all, make sure that you know in which quadrant this complex number is. Now, if you see this first value that is on the real part is positive, and then the second part, which is on the imaginary part, is negative. It is here. This is the negative y-axis. This is the positive x-axis, meaning that this complex number is going to be in this quadrant here. So whenever you are finding angles, you are always going to find the angle related to the positive x-axis, to the x-axis. So if this is your Cartesian plane, you have got a complex number in this quadrant. If you do the tan inverse, the angle you are going to find is this one. That is always related to the x-axis, not this one that is not related. If the complex number is here, the angle that you are going to find after punching the tan inverse is going to be this one, not this one. If the complex number is here, the angle you're going to find is going to be this one, not this one. If the angle is here, the angle you're going to find is this one, not this one. In other words, the angle that you find when you punch tan inverse is always related to the x-axis. Now, if you look at this complex number that we have, square root of 3 minus I, the x-axis you can see is the square root of 3. The y-axis, just get the number in front of the I. That is what? A negative 1. Okay, that's is going to be a negative 1. Just get the number in front of I. So to be able to find argument, I'll pick it from this point. Theta is equal to tan inverse of y divided by x. It is the same as me saying tan theta is y over x. I've just taken the tan in advance the other side. So here we're going to have theta being equal to tan inverse. Where there is y, the y value you are able to see, it's this one. It's a negative 1. But I'll not get a negative. I'll just get a positive 1. And then over, over the x value. The x value is what? Square root of 3. Like that. So theta is going to give us, we go on the special angles, 1 over square root of 3. We can see 1 over square root of 3 is related to a 30 degrees. Tan 30 is 1 over square root of 3, meaning that tan inverse of 1 over square root of 3 is going to be 30 degrees. But remember, this angle is not in the first quadrant. Okay, it is in the fourth quadrant. This angle is here. So we have found this is the 30. Whenever you are finding angles, angles are always measured from the positive x-axis going in the anti-clockwise direction, like this. That's how you measure angles. Whenever you measure an angle in this direction like this, it's always going to get a negative sign. So this is going to be negative 30 because this one was also negative. Whenever you are measuring angles going down, they are always going to be what? Negative. But when you measure angles going in this direction, they always be positive. So the final answer can be given as theta is equal to negative 30, or you can say this is a 30 here, but you want the angle starting from the positive x-axis going in this direction up to where this angle is. Now this was supposed to give you 360, but you know that this is a 30. How can you find the missing one? So it will be 360 minus 30, and that is going to give 330. So this is a 330. That's the argument. or negative 30. But every time you're working with angles, give the positive form. It is better. So this is going to be 330 degrees as the argument for this one. Now, as you get to read some books are going to tell you argument should be given between negative 180 is less than or equal to theta, which is less than or equal to 180. That means don't give a number or a value that is greater than 180. So if you see this, all we are saying is when you are giving the final answer, instead of you giving 330 degrees, don't give that. Give this one, because you only want to give numbers between negative 180 and positive 180. This one is outside. So instead of writing this form, you write this form. It is all the same answer. It is just the preferable form that the examiner is asking for. Let's look at another one to make sure that people have understood. Let's say we've been given a complex number z, which is equal to, let's say, negative 1 minus square root of 3i. We want to find the argument of this complex number. First thing first, let's see in which quadrant this complex number is. So we can see that the real part is negative, the imaginary part is also negative. You ask yourself, in which quadrant is both x and y negative? So this is the negative x, this is the negative y, meaning that this complex number is going to be here. So if we are finding the angle, which angle are we going to find? Is it this one or this one? Let me put, is this going to be A or is going to be B? Which one do you think? When you punch tan inverse, which angle are you going to calculate? Is it this angle A or is going to be this angle B? Anyone to speak? Yes, yes, Arnold. You can say that again. Okay, it's going to be A. The angle that you calculate should always be related to the x-axis. So this is going to be A. Okay. Now you can even see that the arrow is going in this direction, meaning that the angle that you are going to calculate is going to come out positive. Okay. Now let's get to calculate. We see what we are going to find. So here we need also to see what is going to happen. The x value, we can see that is a negative 1, so this is negative 1. The y value is negative square root of 3. Therefore, we know that theta is given by tan inverse of y over x. Therefore, we're going to say theta is going to be equal to tan inverse. The y value is negative. The x value is also negative, and negative over negative is a positive. But as I said on the previous one, just take both of them as positives. So y, we can see that is what? Square root of 3. X is a 1. Square root of 3 over 1 is just the same as square root of 3. And which special angle is related to tan of square root of 3? We know that tan of square root of 3 is 60 degrees. Okay, is 60 degrees. That means tan inverse of square root of 3 is going to be equal to, tan of 60 degrees is square root of 3. Meaning that tan inverse of square root of 3 is going to be 60 degrees. Now, if you look at this angle we are talking about, this angle is in this quadrant. Whenever you are measuring angles, always measure them from the positive x-axis. That means I should either get this angle like this, or I should get this angle going down like this. So if I get the one on top, starting from this point going like this, the question is, what value is it going to be? Now, we already know this as 60. And we know that this one here is what? Is 180. So just add 180 to this value that you have. 60 plus 180, that is going to give us 0 first. 6 plus 8 is, that is a 14. So 4 remainder, 1. So that is going to be 240 degrees. So if we measure in this direction, we're going to get 240. But if we measure in this direction, you can see this is supposed to give us a straight line like this. But we've been given this angle which is here. We've been given this one and we want this one that is missing. So to be able to find that one, it will simply be 180 minus this one which we've already calculated, the 60. And this is going to give us 120. But notice that because we are going in the clockwise direction, we're supposed to attach a negative there. Okay, so that is it. So whether we give negative 120 or positive 240, it's the same thing. That's the same angle that we are talking about. So this is how we get to find argument. Just finding the angle. Now if you go in physics, that angle is called the direction. Okay. Do you have questions? Yes, Jacob.